Hello, everyone. Welcome back to the Microcontroller Application Technology course. Today, we will learn about the static display of a single digit using a display. We will delve into the principles of display operation, display methods, and program interpretation. By the end of this lesson, you will understand the principles behind displaying digits on an 8-segment display, the use of the P0 port on a microcontroller, and how to design a program for static display of a single digit. In modern production, it is often necessary to display information such as temperature, humidity, or time. Common household appliances and electronic products like air conditioners, washing machines, refrigerators, and rice cookers also need to display numeric information such as temperature, usually achieved using a display. First, let's analyze the principle of the display. This common type of display uses 8 internal LEDs to show digits. There are 2 types of displays: common anode and common cathode. In a common anode display, all the positive terminals of the 8 LEDs are connected together to form a common terminal, whereas in a common cathode display, all the negative terminals of the 8 LEDs are connected together to form a common terminal. Here are the pin diagrams and internal circuit diagrams for both types of displays. Taking a common cathode display as an example, let's discuss how to correctly display a number. In a common cathode display, the negative terminals of the LEDs are connected together to form a common terminal, labeled as COM. Now, think about this. What would happen if a high-level signal is input at the COM terminal? Regardless of whether a high or low signal is input at the 8 input terminals, these signals cannot turn on the LEDs. The display will not display anything unless a low signal is input at the COM terminal, and a high signal is input at the corresponding input pin to turn on the specific LED. By turning on and off certain LEDs among the 8, any decimal number can be displayed. Therefore, for a common cathode display to display correctly, a prerequisite is to ground the common terminal. Often, the common terminal of the display is considered as the chip select pin. The display will only be operational when the chip select pin is at a valid level. For a common cathode display, the chip select pin needs to be at a low level to display correctly, otherwise, the display will be in a dormant state and show nothing. The chip select pin COM can be grounded permanently or controlled via a control line. Now, let's see how exactly a display displays a digit. To display the number 3, for instance, let's analyze how to achieve this. To display the decimal number 3 on an 8-segment display, as shown in the diagram, you simply need to turn off the segments D, P, F, and E while turning on the rest to display the number 3. So, how do we control the illumination of these 8 LEDs according to this pattern? For a common cathode display, when a low signal is input at the COM terminal, to turn on a specific segment, you just need to input a high signal to the corresponding input pin. To turn it off, input a low signal. Therefore, by inputting a control data of 01001111 to the input pins DP, G, F, E, D, C, B, A of the display, you can achieve this. This binary number can be converted to hexadecimal as 4FH. From the analysis above, it's evident that each decimal digit to be displayed on an 8-segment display corresponds to an 8-bit binary control number. This 8-bit binary control number is referred to as the character code for the display. It is detailed in the table provided. The principle for a common anode display is similar, with the distinction being the logic levels. Since we have already covered the display principle of displays, we won't delve into it further here. How can we use a microcontroller to display a single digit on a display? In this example, the illumination of the display is controlled by the output levels of the P0 port. The basic usage of the P0 port is similar to that of the P1 port, but there is one important note. P0 port is primarily used as an input port, so each pin must be connected to a pull-up resistor due to the internal structure of the P0 port. The size of the pull-up resistor can be calculated based on the external circuit, typically in the range of 200 to 300 ohms. Now, let's design a program for static display. The program consists of the main function. In the main function, the character code for the digit to be displayed is sent to the P0 port, and a loop is implemented. Firstly, the special function registers of the 51 microcontroller are defined. Below is the main function. When the condition is met, loop P0 equals 0x4f, which is the character code for displaying the number 3. Next, we will simulate this using Proteus software. Firstly, we connect the circuit in Proteus according to the hardware circuit diagram. Then we write the program using Keil software, compile it to get a hex file. Load the hex file obtained into the microcontroller chip in Proteus. And start the simulation to observe if the display displays correctly. Through this exercise, you should grasp the display principle of displays and the program design for statically displaying a single digit. After class, you can try sending different character codes to the P0 port and see if you can achieve the desired display. Finally, here are a few homework exercises for you to reinforce the knowledge learned today and deepen your understanding. Please make sure to complete them diligently. That concludes this lesson. See you in the next class.